Here we go, looking at our learning target number 5, albedo. What is it? What's the impact to climate? And then evidence, how do we know? So we got some keywords to use as we go through here. Increase, reflect, absorb, ice, and ocean. So again, our first one here is just what is albedo? I'm going to flip over to the slides and kind of follow you through these that way. So you can go ahead and do half screen and fill in your boxes as we go. So this is essentially our number 1, right? What is albedo? Well, it's looking at the amount of solar radiation reflected from a surface. That's what albedo is measuring. And what we've discovered in our investigation here is that different surfaces have different albedos. We have some that measure as high albedo and some that measure as low albedo. And it all depends on the surface's characteristic. So again, what it's measuring is exactly how much solar radiation is being reflected. So if we're using a low albedo, or we have a surface with a low albedo, of all the solar energy coming at that surface, just a small amount is reflected back into the atmosphere, meaning that surface is absorbing a lot, right? And in this particular example, it'd be 90%. Here, a high albedo surface reflects more than it absorbs. So it might be reflecting 80% and absorbing 20%. And so we typically see these low albedo surfaces heat up much faster than a high albedo surface because, again, of what that surface is absorbing. So in your number 1, you're thinking about albedo is looking at solar radiation reflected. There's 2 categories, high albedo and low albedo. And you looked at some different datas in your investigation, and we kind of pulled together a consensus that the high albedos are light-colored surfaces, right? So that was like sea ice, snow, sand was kind of on the higher end there. And then the low albedo, those are the dark-colored surfaces, like soil, forests, and water is one of our lowest albedos. And that's tricky because even though it's not dark, it absorbs a lot because it's actually clear, right? So the solar energy goes all the way through as deep as it can and starts to warm this level and this level and this level. So it's absorbing so much, it reflects very little, even though it looks really bright and reflective to us. So high albedos are light color, low albedos are dark colors. And there's non-natural albedos too. So city materials even have albedos. So we got to think about our number 2 here. What is our impact to climate? Well, what we see over time, especially at the poles, is a lot of albedo, right? A lot of reflectivity happening because there's so much ice there. But because the entire planet is warming up, we're starting to see the ice levels reduce a little bit. And as those ice levels reduce, it exposes more ocean here, allowing more solar energy to be absorbed because, again, solar energy is absorbed more by the ocean, which, as you can see here, warms the water, which creates more ice melt and warming and so on. And you really worked through this visual in your albedo investigation. And you created this positive feedback loop where these events continue to happen towards the extreme, kind of like a domino effect. This creates this, creates this, creates this, and it's never ending, continuing on and on and on, building on itself. So when the oceans warm up, we get ice to melt, which means there's more ocean, which means more solar energy is absorbed because that's what oceans do, which means they warm up, ice melts, more ocean, more absorption. And again, this continues to happen in this kind of quick spiral. So that's our number 2. It creates this positive feedback loop, and you want to list out some of these steps. Warming the ocean, melting the ice, exposing more ocean to heat up, to then melt more ice, and so on. So kind of give a little summary or maybe bulleted lists in your number 2. Now that brings us to our number 3. Well, how do we know this is happening? Okay, we already know that there's an increase in CO2, right? We already know that's happening from more combustion, which increases our global temps, right? So you can put that into a sentence. Now, we're seeing our evidence is that we are actually losing sea ice. We can see it, oh my goodness. We can see it both visually and in the data, right? So you can see here this diagram starts in the 70s and ends in 2012. And so it's a much smaller amount in 2012. I like this visual because it does show that sea ice changes from year to year. But overall, in this span of 30-ish years, we're seeing much less ice total. And you had some numbers in your investigation that you could certainly pull in and use as evidence. One of your pieces of data said we've seen a 14% decrease per decade, right? We've also seen anywhere from 50 to 60% of Greenland's ice go away in the last 15 years, right? So our evidence is this: sea ice is decreasing because of that positive feedback loop. And it's speeding up this process of global warming happening at the poles because of the changing albedo from ice into ocean.